Hello everyone, in this video I'm going to solve question problem 9 and problem 5. So let's go problem 9 first. Here you were given marginal utility of apples and marginal utility of pears for each consumer, and the price of apple and price of pear is given. So to answer this question we need to know first what is the optimal consumption bundle. Optimal consumption bundle is where you have marginal utility from apples divided by price of apples equals to marginal utility of pears divided by price of pears. So if we reach this equality, then the consumer is consuming the optimum consumption bundle that maximizes utility. So the prices are given. PA is 1 and P pears is 2. So we can calculate for each consumer if this condition is satisfied or not. For Kevin, let's see, it's 6 divided by 1 equals or not 12 divided by 2, which this equality satisfied. So Kevin is maximizing utility. Let's look at Maria. Maria, it's 6 divided by 1 equals or not 6 divided by 2, which is not equal. Therefore, Maria is not maximizing utility. And let's continue with the next consumer. Here we have Rajiv. Rajiv has 6 divided by 1 equals or not 3 divided by 2, which they are not equal. So Rajiv is not maximizing utility. And the next one is Simone. Simone, 3 divided by 1 equals or not 6 divided by 2. Yes, this equality is satisfied. Therefore, Simone is maximizing utility. And finally, Yaakov has 3 divided by 1 equals or not 12 divided by 2, which this equality doesn't satisfy. Therefore, Yaakov is not maximizing utility. So the ones who are maximizing utility are Simone and Kevin. So if any of these consumers are optimizing over their fruit choice, yes, Kevin and the next one is Simone. Others are not, because we don't have this equality. Marginal utility of apples divided by price of apples is not equal to marginal utility pears divided by price of pears. So this is the step 1. Let's move on to step 2. For step 2, we need to find or suggest a way to maximize utility. So Maria, Rajiv and Yaakov are not optimizing over their fruit choices, which we find it, right? Maria, Rajiv and Yaakov are not optimizing. Let's actually circle down with red so you can see it. Maria, Rajiv and Yaakov. So in the following table, indicate which fruit each consumer should increase consumption in order to achieve the optimal fruit consumption bundle. Okay, so let's look at Maria. Maria is receiving per apple 6 marginal utility per price. Per $1 she receives 6 marginal utils for apple, and she receives 3 utils per dollar she spends on pears. So it seems like she's getting more utility per consumption of apple. She's enjoying $1 she spends on apple more compared to she spends $1 on pears. So therefore she needs to consume more apple. When she consumes more apple, the marginal utility per dollar she spends on apple is going to go down. Because just remember, diminishing marginal utility, you consume more apple, your marginal utility is going to go down, and we can be able to reach the optimum if we can reduce this number. I'm repeating again, Maria should consume more apple because she's getting more value per buck she spends on apple. As she consumes more apple, the marginal utility per dollar she spends on apple will go down, and then we will reach to an optimum level for her. For that reason, apple is the right choice. For Rajiv, let's look at here. Again, Rajiv is receiving more utility per dollar he spends on apple compared to pears, right? He's receiving 6, whereas per per dollar on peers is 1.5. Therefore, Rajiv needs to increase the consumption of apple. For Jakob, per dollar he spends on apple, he receives 3 utils. And for peers, he receives 6. So peers giving more utility per buck. Therefore, he needs to increase peers. So the right answer is Maria apples, Rajiv apples, Jakob peers. So let's check question 7 or problem 5. So what we have here, a college student has 2 options for meals. Eating at the dining hall for $6 per meal or eating a cup of ramen soup for $2 per meal. Their weekly food budget is $50. Assume that they spend equal amounts on both goods. So we have the budget 50% to 50%, right? You spend 50% on meals, 50% on ramen noodles. First, we are going to draw the initial budget constraint. So we need 2 points to draw a budget constraint. If you have $60 and you spend all that money on meals, then you can buy 10 meals. So 10 meals and 0 cups of ramen soups is 1 point. If you spend all money onto ramen noodles, you can buy 30 cups of soups. Okay, so that is soup. So let's go here. Let's first choose this line. And we know that if we spend all the money on dining meals, you get this much, right? 10 meals, 0 ramen noodles. If we spend all on ramen noodles, we get this much. So this is our budget constraint. So we draw the budget constraint. And next we need to find the initial optimum where you spend $30 on meals. $30 on meals, each is $60. That means 5 meals. And $30 on ramen noodles, which means 15 soup. So let's find out this initial equilibrium. 15 soup. Okay, this is the initial equilibrium. Now let's continue reading. Suppose the price of a cup of soup now rises to $3. Assume that the student now spends only 20% of their income on dining meals. So now 20% of income is on dining meals. $60 times 20% is $12. So with $12, you get 2 meals. And the remaining $48, you're going to get 16 soup. So as you see, soup amount increases. The price increases, soup amount is increases. On the preceding graph, use the blue line circle symbol to draw the college student's new budget constraint. So in order to draw the new budget constraint, right, we need to again think that if we have $60 and spend all of them to meal, we have 10 meals. But now for the soup is different because the soup price is 3, so 20, 10, 20. Let's draw that one. Right, 10 is still the same, but now the soup amount has changed to this. So this is our new budget constraint. And now the new optimum is going to be, as I said, 2 meals and 16 soups, because you're spending 20% of your income on meals and the remaining on soup. So this is going to be where? Yeah, this is the new optimum. As a result of this price change, the quantity of ramen soup cups consumed increase. As you see, it was 15 before, now it's 16. This means that the ramen soup must be an inferior good. So how we can explain that it's an inferior good? First of all, with the increase in price of the ramen noodle soup, you have your income relatively goes down because now one item is expensive. So as your income goes down, you buy more of ramen noodles, okay? For that reason, it should be an inferior good. Just remember that if your income increases, you buy more of the normal good. And the reverse is true too. When your income decreases, you buy less of the normal good. For inferior goods, when your income increases, you buy less of the inferior good. When your income decreases, you buy more of the inferior good. So that happens here, right? Ramen noodles are now bought more by the consumer, right? For that reason, this means that ramen soup must be an inferior good, and the income effect outweighed the substitution effect, because if we talk about substitution effect, you usually substitute the expensive one with the cheaper one. But since you are buying more soups, income effect outweighed the substitution effect in this case. And finally, let's see if a cup of ramen soup is a giffen good. So when it's $2, remember that we find out here the student is consuming 15 soup. Let's circle that. Okay, so $2, 15 soup. And when the soup price increased to $3, then the student is consuming 16 soup. So therefore at $3 it is 16. So as you see, we have an upward sloping demand curve. Upward sloping demand curve is the same as you have a giffen good. For giffen good, we have upward sloping demand curve. Therefore, this statement is true. Thank you for watching this video.